Hi everyone, welcome back to the RBT Security YouTube channel and welcome to part 1 of our Kubernetes penetration testing series. In today's video, we will explore how attackers gain access to Kubernetes clusters from an external point of view. We will show you how to compromise containers and begin lateral movement inside the cluster. Before we proceed, please take a moment to subscribe if you haven't done so already. Don't hesitate to comment below with any other great content you would like to see. Let's get started by scanning for any exposed services. We are going to use an external model. We will use the Nmap to scan the IP 192.168.115.135, which is the IP of the master node. We see three different open ports. One of them is the port 80, which is hosting a web server. Let's analyze deeper. It looks like the main function of the web application is to encode the user input to base64. We test for command injection vulnerability on the exposed web application. This app appears to base64 encode user input, but is vulnerable to remote command executions. Let's try to identify a Python is available inside of the container. And as you can see, it looks like a Python is available. As you can see, the web application execute system commands. This confirms command injection vulnerability. Let's weaponize this vulnerability with a reverse shell payload to gain remote access to the container. The first thing that we need to do is to set up a netcat listener, copy our payload, and transfer to the vulnerable web application. Paste it, execute it, and go back to our Kali machine. And we have a shell access inside the container. Let's run a few commands. Let's upgrade this shell into a full TTY shell for stability and usability. Now that we have tab completion and interactive support, which is a critical step for deeper post-exploitation, we can start and investigating the container. Let's conduct a reconnaissance on the environment. And as you can see, we are operating under the root user context. And look at that, it looks like we are inside the Kubernetes pod. So we managed to successfully retrieve sensitive information such as IPs and ports. Let's see if we can identify mountain volumes or services account secrets such as API tokens. It looks like the token file is available. Let's try to retrieve its value. We were able to retrieve the token's file value. We can use this token to interact with the Kubernetes API service. Let's do that. And look at that. It looks like we were able to successfully interact with the Kubernetes API services. We successfully managed to list all the pods in the default namespace with a lot of details for each pod, such as pod metadata, pod status, pod spec, and events and status reasons. Let's check for classic privilege escalation misconfiguration on the container, such as privilege flags or mounted Docker sockets. And as you can see, in this scenario, we didn't identify any some sort of misconfigurations. However, when the privilege flag is used with a container, it will give all Linux capabilities to the container. capsys admin, capsys ptrace, and capsys module are some of the dangerous capabilities that an attacker will need to looking for. If an attacker gains access to the container with this type of capabilities enabled, they can load malicious kernel modules directly into the host kernel. This can lead to different circumstances, such as privilege escalation, persistent, or system compromise. Additionally, if Docker socket is mounted, the container can control Docker, providing the container with a root level access to the host Docker daemon, which can possess significant security risks. In this first part, we move from a single exposed web service to full container compromise using real adversary techniques. We gain shell access, spawn a shell, and enumerated the Kubernetes environment, exposing sensitive paths, tokens, and potential attack vectors. This is exactly how external expose leads to the internal compromise. In part 2, we will go deeper, escaping out of the container by exploding Docker socket, abusing privilege flags, and attacking the underlying host. Make sure to follow RBT Security for the next phase of the Kubernetes penetration testing series. See you in part 2.